hardware components. Okay, so here they give you an example of some specs on a computer. You have your processor, your RAM, your hard disk, wireless card, and your monitor. Here they're kind of showing you the bus. So the bus lives on the motherboard. The motherboard is a component that connects all of the other computer components together. So it allows a signal between all these different components. Memory. So memory can be divided into different locations. Each memory cell has a numeric address which uniquely identifies it. Each cell stores a set of bits, usually 8 bits or a byte. For values bigger than 8 bits, we use consecutive memory locations. It's important to remember that main memory is volatile, meaning that once it loses power, that information is removed from the main memory. On secondary devices, they're non-volatile, so that means like once they're powered off, the information is kept stored on those non-volatile devices. The CPU, okay, this is kind of important. So the CPU, depending on which cycle it's on, it's going to fetch, decode, or execute. That's the way it processes instructions. It fetches the instruction, decodes the instruction, meaning figures out what needs to happen, and then it will execute that instruction. Within the CPU, there's like pretty much a completely other architecture going on there. Whenever you take a computer architecture class, you'll learn more about the CPU. There's some basic components of the CPU, which is the arithmetic logical unit, the control unit, and its registers. The speed of the CPU is controlled by the system clock. The system clock generates a pulse at regular intervals, and that's the read time for every signal. So here's a drawing of the CPU. So I wanted to show you the electrical signal coming in. So here's a signal coming into the CPU. Then here's a signal coming out of the CPU. It's going to use the RAM to store information as it's processing instructions, like say for a program. But also internally, there's a lot going on in here. You can take an architecture class and learn a lot about how the CPU actually accomplishes its job. But for the sake of this class, we're just going to talk about the fetch, decode, and execute. Okay, so the CPU is constantly fetching, decoding, and executing. So it's important to know that the signal coming in here is actually electrical signal. So that means it's like pulsing like this. And a cycle is like from one point to the other, like when it gets back to its point. So there's some cycles here. So in this cycle right here, the CPU would be fetching. Right here would be decoding. Right here, it's going to execute, and then it's going to keep doing this process over and over and over again. Now, this signal is controlled by the system clock, so it can be within gigahertz, right? So that just means that this is being processed within fractions of a second. So within fractions of a second, the CPU can do this millions of times. And that's how programs are ran. So the CPU is constantly fetching and decoding instructions and executing on those instructions. Now, this electrical signal, it's also important to note that this bus here, this is the bus, is 64 bits. So that means like there's 64 lines of communication. Okay, and each one of these lines can either be charged or not charged. That means it can either represent a 1 or a 0. You can have a 1 or 0 here, 1 or 0 here, and so on, so on, so on, so on. So that means you have 2 to the 64 possible permutations. So what that means is within one cycle, you can represent 2 to 64 different permutations. And this number comes out to be 1.8 times 10 to the 19th power. So that's a lot of information that you can process within fractions of a second. So this is how the CPU accomplishes its job.